Okay, we'll be covering for this video, right? We'll be covering indices, chapter 2.2 of your AMath textbook. Okay, but we won't be covering example 8 and 9 because it's just an extension of your AMath indices. So I'll not be covering that. I'll jump straight to example 10, 11, and example 12. Okay, so we'll start with example 10 first, which is on page 45. Okay, the question goes like this. Simplify this particular expression, 81 to the power of x plus 1 plus 3 times 9 to the power of 2x. Okay, the whole thing divided by 3 to the power of x minus 2 multiplied by 9 to the power of x plus 1. Okay, and we must make it in the form of a to the power of x. Okay, so it looks daunting at first. Okay, so what we can do is we just work with the law that we learned in AMath and see where we can go from there. Right? So for the first part, okay, let's look at the numerator. What can we do with the numerator? Okay, in AMath, we learned that 81 to the power of x multiplied by 81. Okay, we can combine the powers. Okay, we add the powers together. Okay, so in AMath, remember when we learn maths, right? If the forward is true, okay, the backwards must be true. Okay, so that means if we multiply the same base, okay, we can add the powers. If the powers has been added, we can break it up into the multiplication. So that means this numerator will now be 81 to the power of x multiplied by 81, but I wrap to the power of 1. Okay? And so that's what they got in the first place. Okay. Then the next part, this one. Okay, what can we do here is that this is base 81, this is base 9. When the base are not the same, we can't do much. So what we can do here, let's say 9 2x can also be written as 9 squared and then to the power of x on the outside. Okay, so if we learn in AMath this, okay, can become this. We learn in AMath that the backward is true. That means we can break it up into this. Okay, but 9 squared is 81, so it becomes 81 to the power of x. So 9 2x is actually 81 to the power of x. Okay, so I erase this plus a 3 of 81 to the power of x. Okay, that's the numerator alone. Okay, let's see what we can do with the denominator. Okay, for the denominator, we'll be doing the same thing. Okay, we're going to split it up, but I'm going to use 3 to the power of x multiplied by 3 to the power of minus negative 2. Okay, I know we can use division. Okay, minus we just use division, but because we are dealing with fractions, right? Then we divide and stuff. It gets messy, so we make everything multiplication. Okay, so we multiply by the negative of it. Okay, which means the same thing. Okay, for this one, we're going to break it into 9 to the power of x multiplied by 9. Okay, let's see where we can go from here. From here, the top portion, okay, you need to see this. This is 81 to the power of x times 81. So we see this as one term. Okay, and then there's plus in between. And then there's another term over here. So it's an addition of two terms. Okay, so because it's an addition of two terms, there is a common term here. There's 81 to the power of x here. There's also 81 to the power of x here. So we can take out or factorize the 81 to the power of x. Okay, and we are left with, over here on the left, there's 81 left. On the right, there's 3. But it's plus, right? So plus 3. Okay, this one, 81 comes from the first term, plus the 3 comes from the second term. Okay, for the bottom part, okay, what we're going to do is all the ones with the similar power, like for example, this one is to the power of x, this one to the power of x. Okay, what we learn is we can actually, if they are not the same base but they are the same power, we can actually multiply them together, multiply the base, and keep the top. Okay, so 3 times 9 to the power of x. Okay, this one, 3 to the power minus 2 is 1 over 9. This is 9. So the numbers can get multiplied together. So 1 over 9 times 9 is just 1. So in your book, they write 1 over 9 times 9. So it's just going to be 1. Okay, so take note, all the numbers, group them together. All the ones with the same power, group them together. Okay, right. What else we can do is that here we are left with 81 to the power of x. Here we are left with 84. Okay, over here, this is 27 to the power of x. Okay, I'll obviously put it directly below 81 to the power of x. And then over here is just times 1, so I'm not going to write anything. Okay, But the thing is, we learned that if they are the same power and then we divide different bases, okay, what we can do is, here, this is actually equals to your 84, I'll take it out. This is 84, take it out. And then here is 81 over 27 to the power of x. Okay, because they are the same indices or index, okay, we divide and keep the top. Okay, 81 divided by 27 is 3, so it's 84 times 3 to the power of x. So we have converted it into 84 is your A, 3 is your B, so it becomes A, B to the power of x. Okay, we have put it in this particular form that we want. Right? So I'll continue with part 2, but I will erase the boxes. Right, let's continue with our part 2. Okay, so part 2 says that if this particular expressions, okay, we're not simplifying anymore, okay, what they say is if this particular expression is equal to 28 times 3 to the power of y, show that y equals to x plus 1. Okay, so since we have simplified earlier, this particular portion can be simplified into 84 times 3 to the power of x. We can say that if this is equal, then 84 times 3 to the power of x is equal to 28 times 3 to the power of y. Okay, right, for the book, they put the 3 to the power of y over here. Okay, and then after that, they divide 28 to the other side. That means 84 divided by 28. So you get 84 over 28, okay, times 3 to the power of x. So basically, they just shift this here. Okay, so this 84 divided by 28 times 3 to the power of x is written on the right side, and then 3 to the power of y is written on the left side, but it means the same thing. Okay, right. So 84 divided by 28 happens to be 3. Okay, so we arrive at 3 to the power of y equals to 3 times 3 to the power of x. Okay, but we can't do much unless there's only one base on the left and one base on the right. So we need to use our law, okay, to calculate this. So this is 3, which is 3 to the power of 1. And it's times by 3 to the power of x. So we know by law 1, when we multiply the same base, we just have to add the power. So I write it as x plus 1. 1 plus x and x plus 1 means the same thing. Okay, so if 3 to the power of y is 3 to the power of x plus 1, okay, the base is the same, therefore the indices must be the same. Okay, therefore y is x plus 1. Okay, and we have proven, okay, hence y is x plus 1. Right? Okay, so why don't you give a try for try 10? Okay, and we'll continue with example 11 after this. We are back. Now we are doing example 11 on page 45. Right. The question goes like this: given that u is equals to 2 to the power of x, okay, 2 to the power of x, express each of the following in terms of u. Okay, so we are supposed to convert everything in terms of u. That's the basic idea. Okay, so let's try the first one. Okay, we get 2 to the power of 1 minus x. Okay, so similar like what we've done in the previous example, we're supposed to learn how to break this up. Okay, so this is 2 to the power of 1 multiplied by 2 to the power of negative x. Okay, of course some of you may see it as 2 divided by 2 to the power of x, also possible. Okay, right, so this is 2 times 1 over 2 to the power of x. Okay, but we are given earlier that 2 to the power of x is written as u, so this is, when you simplify, is 2 times 1 over u. So it's just 2 over u. Right, so that's for the first one. Okay, now we move on to part B, which is on page 46. Okay, they give us 4 to the power of x minus 2. Okay, then what we can do here is, instead of writing 4 to the power of x minus 2, we're going to change it to 2 squared. Okay, the 4 we change it to 2 squared to the power of x minus 2. Why we do so? Because our base must be 2. Okay, so that it will be in the form of u. If our base is 4, we can't do much. Okay, so we change it to the base of 2. Okay, and then this one, okay, we can break it up. Okay, this is 2 to the power of 2x. Okay, so it will be 2 to the power of 2x. Okay, and then minus 2, right? So it's times, okay, this is 2 to the power of negative 4. So 2 to the power of negative 4. Right? Okay, for this part, okay, I'll do a side working first, then I'll erase. Okay, 2x, okay, can be written as 2 squared, and then we bracket x, or can be written as 2x, and then the square is on the outside. Both means the same thing. Okay, so we're going to change this into the second one. Okay, this is 2x squared. Okay, then this one remains the same. Okay, so I erase this part. Okay, right, then for this part, this is 2 to the power of x is given as u. So u squared, this one is 1 over 16. So it's u squared over 16. Right? Okay, I'll do part C, but I will erase the others first so that you don't get confused. Okay, we're back. Here we do part C. Okay, part C, the base is 16, but our base is 2. Okay, so similar to part B just now, we will change this. Okay, first and foremost, let's change this into the fraction part. We know cube root is linked with fractions, so it will be 16 to the power of x over 3. Okay, this will be the numerator, the 3 will be the denominator. Okay, from here we change the 16 to 2 to the power of 4, and then we have our x over 3. Okay, so now we do a flip. Okay, the x goes in, the 4 goes out, because 4x and x times 4 means the same thing. Okay, so the x goes in, the 4 goes out. Okay, they both multiplied to be the same number, so it doesn't matter who goes in and out. But when we put the x inside, this becomes 2 to the power of x, which happens to be u. Not u lah, but u. Okay, so it will be u to the power of 4 over 3. Okay, and we are done. Okay, so if you look back at page 45, turn one page back, there's try 11. So you give it a go with try 11, and we'll end off with example 2 after this. Our last example for Indices 2.2, it will be this example 12. It is given as such. If you read 3 to the power of 2x, we are given 3 to the power of 2x plus 4 multiplied by 5 to the power of x minus 2 is equal to 3 to the power of 3x multiplied by 25 to the power of x. Okay, and the first question wants us to evaluate 15 to the power of x. Okay, as of now we do not see any 15 going on. Okay, so it's kind of hard to find a way out, so we just make do with whatever law that we have learned. Okay, so in AMath there's a lot of this splitting technique, so we will do that first. Okay, so this will be split into 3 to the power of 2x multiplied by 3 to the power of 4. Okay, because it's plus, so we can split it into a multiplication of the same base. Okay, for this part, we will do likewise, so it's 5 to the power of x multiplied by 5 to the power of negative 2. Okay, similar for this part. Okay, so for this one we can't do much, it's just 3 to the power of 3x. Okay, for this one, we can actually change it to, maybe I change it straight away, 5 to the power of 2x. Okay, in your book, they change it in the next step. Okay, how I get this 5 to the power of 2x? 25 is actually 5 squared. So it's 5 squared to the power of x. So it's 5 to the power of 2x. Okay, so I do a side working. 25 to the power of x is 5 squared, but to the power of x. So it's the same as 5 to the power of 2x. Okay, so let's erase this side working. Okay, let's continue. What we're going to do next is we're going to group all the to the power of x together. So we get 3 to the power of 2x and this 5 to the power of x. Put them together first. Okay, but the numbers we can evaluate them. Okay, so this 3 to the power of 4 is 81, and this 5 to the power of negative 2 is 1 over 5 to the power of negative 2 is 1 over 5 squared. We know that when we flip, the negative sign changes to a positive, and 1 over 5 squared is 1 over 25. So we can write this as 84 times 1 over 25 is 84 over 25. Okay, and that's how you get the not 84, 81. Okay, thank you very much. This is 81 over 25. Right? Okay, on this end we stick to status quo, we don't change anything. Okay, right. Next, what we're going to do is anything with the power of x is going to be shifted to the left. Okay, just like how we solve our normal x question, our x is always on the left and the numbers are always on the right most of the time. Okay, so similarly, any powers that is x, we move it to the left, any numbers, we move it to the right. Okay, so what happens next is, okay, we're going to shift this to this side. Okay, the book does it slightly differently. So the 81 over 25 remains. Okay, but this one will be 3 to the power of 3x times 5 to the power of 2x. Okay, they skip a step, but I'll just continue. This time when you bring over, it becomes divide 2x and then divide by 5x. Okay, it's still multiplied. That means these two, they are multiplied together and then they come down together. Okay, so we put it like this. Okay, the book doesn't do it this way, they skip steps. Okay, so let's do the 81 over 25 over here. For the book, you'll see the 81 over 25 is on the right. Okay, alright, so here, the one with the same base, we can do something to the power. So this is 3 to the power of 3x divided. Okay, fraction means divide, divided by 3 to the power of 2x, so it's 3 to the power of x. Okay, 3x minus 2x is x. Why we minus? Because same base and we divide them. Okay, same base, we divide them, so this is 5 to the power of 2x minus, divide by 5 to the power of x, so we subtract the power. So we times by 5 to the power of x in total. Now if you can't see, you can open up the brackets and see how they cancel each other out. Okay, alright, so this one is multiplying different bases but with the same power. So that means we have to take 3 times 5 but to the power of x. We keep the base. We keep the top. Okay, so that means this is 15. So I'm going to write the 15 here. To the power of x is this 81 over 25. Okay, so they ask you why is 15 to the power of x is 81 over 25. Alright, I'll continue with part 2 after this. Alright, we are left with the last part of example 12, part 2. Okay, we are now left with part 2. Okay, I'll leave our previous answer 15 to the power of x is equals to 81 over 25 from part 1. I'll leave it there for later. Right, so for this question, we are supposed to find the value of 5 multiplied by 15 to the power of x. Okay, sorry, root 15 to the power of x. Okay, so first thing first, the book teaches you to calculate this without the 5. Okay, so let's calculate root of 15 to the power of x. Okay, previously we calculated 15 to the power of x is 81 over 25. So it will be square root of 81 over 25. Okay, and as we know, when we want to calculate square root of fractions, it's the same as calculating the square root of numerator divided by square root of denominator. Okay, so square root 81 is 9, square root 25 is 5. So square root 15 over x is actually 9 over 5. Okay, but if they want 5 times of, okay, square root 15 to the power of x is 5 times of 9 over 5, which means the answer is 9. Okay, so that is for part 2, right? And you can go on and try the homework. Okay, remember, teachers don't just teach professionally, but we teach professionally.